All right, folks. So what I would like to talk about today is just some general principles when it comes to graphs of equations. Some principles that apply to more situations than just linear equations, than just lines. And to begin with, I want to talk about what is the meaning of solution when your equation has not just one variable, not just x, but two variables, maybe x and y. Now, if your equation has two variables, your solution has got to consist of two numbers, of a pair of numbers. And we say an ordered pair of numbers because we're going to agree that the first number is going to represent the x value, and the second number is going to represent the y value. An ordered pair of numbers replacing both x and y. Once again, the goal is to make the equation true. And we call that first number in an ordered pair, which is also called a point, the first number is called the x-coordinate. Whereas the second number in the ordered pair, the second number in the point is called the y-coordinate. So I kind of like this, x comes before y in the alphabet, and so in the ordered pair, x comes before y there as well. So, for example, someone gives us the ordered pair, gives us the point 1, 2. Is that a solution to y equals 3x minus 1? So take a moment. In the pair 1, 2, who is x and who is y? The first number, 1, is the x-coordinate. 1 is x. The second number is the y-coordinate. 2 is y. So let me replace x with 1, and let me replace y with 2, and check and see if the result is a true statement or a false statement. Is 2 equal to 3 times 1 take away 1? This turns out to be a true statement. So my answer to this question would be yes. 1, 2 is a solution. Okay. Now, one of the major differences between an equation with one variable and an equation with two variables is that for an equation with one variable, the number of solutions is usually pretty limited. It's unusual to get an equation that has more than maybe a dozen or so solutions. But for an equation with two variables, because you have this extra sort of degree of wiggle room by having both x and y, an equation with two variables will often have infinitely many solutions, more than you could ever possibly write down in your lifetime. And since we can't list the solutions to an equation with two variables, we need some other way to represent it, and we do that using a picture, and that's called the graph of an equation. The graph of an equation with two variables is a visual representation of all its solutions. So for example, a point like 1, 2 would be on the graph of y equals 3x minus 1, because 1, 2 was a solution to that equation. Now, what if I changed that point? And what if I said, what about 0, 4? Is that on the graph of y equals 3x minus 1? To answer that question, I'll need to check whether this point is a solution to this equation or not. But if I plug it in, I get a false statement. And that means that 0, 4 is not a solution. And that means that 0, 4 is not on the graph. All right, now the actual process of coming up with a graph from scratch, if you have no idea what shape the equation is supposed to take on. The general process is to construct a table of x's and y's, which you know will satisfy the equation and make it true. For example, we have found that if x is 1, then 3 times 1 minus 1 is 2, and that's on the equation's graph. If x is 0, then 3 times 0 minus 1 would be -1, and that would be the y value that is associated with this particular x. If x is, say, 2, and I have 3 times 2 minus 1, the y that would have to be associated with that would have to be 5, 6 minus 1. And so I could begin to construct a graph of that equation by writing down the points that I have found in this table. For example, this first point, where I will travel 1 unit along the x-axis, 2 units along the y-axis. That would bring me to 1, 2. This point, where I'm not going to travel any units along the x-axis, I'm going to travel down 1 unit on the y-axis, would be the point 0, -1. This point here, x equals 2, y equals 5, up here somewhere. This is the point 2x, 5y. Your process would be to come up with a bunch of these points, to draw each of these dots, and if you draw enough dots, a pretty clear shape will begin to form. And you'll be able to connect the dots to represent all the solutions to this equation, all the solutions forming this entire line.